viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Arabhat College, University of Delhi. So as you all are aware of the fact that presently we are going through the lecture series of operating system concepts, and in our some of our previous lectures we have actually seen what is operating system, what are the different views regarding operating system, what are the different views of operating system, and we have also seen the role of operating system, which is basically kind of, we can say it acts like a manager, and why it is more known as a manager of the computer system. All those things we have already covered in our previous lectures. So with that background, let me come to this lecture, which is having the agenda of components of operating system. So as you all know that this operating system is basically system software, and it's a kind of, I can say, pretty complex software, and it is divided into various modules, various components to perform their well defined tasks. So many tasks are there which are performed by operating system, and we have already seen those tasks. So corresponding to those tasks, there are various components inside this complex system software, and these components are designed in order to perform those particular tasks. So basically, if we can see operating system, these operating system differ in the structure, but logically they have similar components. They have components for file management, they have components for managing the security issues, they have components for management of input output devices, and so on and so forth. Each component here is a well defined portion of that particular software or that particular system, we can say, that appropriately describe the functions, inputs and outputs. So this module, we have different small components or modules, we can say. So these are there with functions, what functions that module is going to be performed, what will be the inputs which that module is going to receive, and what is the output that module is going to produce. So based on these characteristics, we will be we will be looking through, we will be learning the components of operating system. And as far as we know that in accordance to the services they provide, here we have 8 components of this operating system. Let me name them first, and then we will go through in the details. So first is the process management component. All these are components. Then we have input output device management component. Then we have file management component. Then we have network management component, main memory management component, and a component responsible for secondary storage management, the component which is responsible for security management, and also we have the component corresponding to command interpreter systems. So if you can go through this list, if you can see this list, we have process management, input output device management, file, main memory, secondary storage management, and so on and so forth. So what are these? These are basically services which are provided by the operating system. But today we are not going to look the operating system as the provider of these services. Instead, we are going to closely look at the characteristics of those particular modules which are required in order to provide these services. So let's start with the first one, which is the process management. Now when we talk about process, the first alternative word which comes into our mind is program. So what is the difference between process and the program? A process, you can say, is a program or a fraction of the program. So process, I can say, is a kind of a smaller version of the program that is loaded inside the main memory and that is ready to be executed, or we can say a process which is getting executed is also a program which is getting executed is the process. So basically process is a program which is in the running state, we can say, or it is a program or a fraction of a program that is loaded in main memory. Now, is it only the requirement of a process being loaded into the main memory in order to get executed? No. It needs various resources. If there is a process or there is a program fraction which wants itself to be get executed, in order to complete its execution, it needs certain resources like CPU time, that is one of the resource. Then we have memory, that is another resource. It also needs some files, and it also needs some input output devices to accomplish this task. So it is just not only being loaded inside the main memory, but it needs these resources like CPU time, memory, files and input output devices in order to finish its task. Now next, so the next concept which we are going to read here is it the only one process which is going to be run by the operating system? So answer here is again no. The operating system manages the multiple processes running simultaneously onto the system and activities. So now when the situation comes up with the multiple processes, that means the operating system has to manage the we can say coordination between the processes. So the activities done by operating system in connection with the process management could vary from just loading those processes into the memory and getting their mess up cleaned, also sharing the resources between those processes, because each and every process is actually striving for some resources in order to complete their execution. So what kind of activities there will be executed in order or in connection with process management? So all these activities will be, here you can see them on the screen. They are create, load, execute, suspend, resume and terminate the processes. Also not only this, but there will be switching among these processes. Now let me explain this switching. So this switching says, let's say there is a process which is in the main memory, and now it has got some turn to take CPU cycles for its execution. Now is it going to remain in the CPU cycles till the end? No, but somewhere it is going to require some other resources, maybe some input output devices, some input from a particular input device is required. So basically what I am trying to say here is there will be switching among multiple processes. So one process comes into main memory and then it may go to CPU, then from CPU it will go to input output devices and so on and so forth. So switching between the processes is required. So now what will happen? Who is going to take care of this switching? Who is going to keep the accountancy whole for this switching, that what resources in what manner, and in a shared system how much resources is being used by which process? Those whole accountancy is also done by the operating system. And here with this process management module, it is the operating system's responsibility to make the processes switch the system among multiple resources, we can say. Also in case of a shared resource, for example we need to have a write space or a storage space which is being used by many of the processes. So these processes are required in order to have a smooth functioning, a better communication or a well defined communication mechanism between these processes is required. So it provides the communication mechanism so that processes can communicate with each other, and this is very very important when we talk about shared resources. And in case of a shared resource, for example a shared data or maybe a shared storage, which is in most of the complicated systems it is going to be a write based shared resource, because which is write based shared resource cannot be given to the multiple processes simultaneously, but if some data is to be kind of read from a resource, multiple processes can read it, that's not a problem. So a synchronization mechanism is also required to control the concurrent access to a shared data which cannot be shared at a single point of time by more than one process. So concurrent access to shared data has to be controlled and some synchronization mechanism has to be there. Why this is required? We need to keep the shared data consistent, otherwise our shared data is going to lose the consistency. Apart from that, it is not only the switching, or it is not only the synchronization. Sometimes here processes may fall into the situation of deadlock. Then the operating system need to allocate or deallocate resources properly in order to prevent or to avoid the situation of deadlock. Now what is deadlock? Let us recall, although we have seen it in a very kind of brief manner, but let's try to recall this deadlock situation. What is deadlock? So there is a process A which is depending on process B for releasing of some resources, so that these resources can be taken by A and A can complete its execution. Similarly, B is also dependent on A for releasing of some resources, so which B needs to use for its completion. Now neither of them, neither A nor B, is going to release the resources, so this deadlock, this kind of situation is known as deadlock situation. So we need the operating system carefully needs to allocate or deallocate resources properly in order to prevent or in order to avoid the deadlock situation. So this was all about how this process management is done, or basically what will be, I can say, the features of the process management module. With this, let us switch to the another module, which is input output device management. Now when we talk about input output devices, that means we are talking about some hardware devices. Now how these hardware devices are going to interact with your operating system? Because your operating system is going to provide an abstract level of kind of, we can say, interface to all the hardware devices. So here it is going to do what? It is going to hide the peculiarities of specific software devices from the user. That means your user is not, neither the user is interested nor the user is going to do anything about the particular peculiarities of hardware devices which are attached. So we need to separate out these details of hardware devices from the user. That means an abstract level is to be built in the between. That abstract level of we can say a wall is going to be built by the operating system. Now why it is needed to be kept separated from the user? In order to ensure the proper use of devices, to prevent errors and to provide users with the convenience and efficient programming environment. Because users, if given the control or charge of hardware devices in a multi-user system, you can imagine the chaos it is going to create. So input output device management is completely in the hand of operating system, and input output device management module is going to do all these things. So it will keep the details hidden from the users, or we can say from the application, in order to ensure proper use of devices. Now looking at the specific, this what we have understood what actually the input output device management is. Now let us try to see what are the tasks of input output device management component. Input output device management component firstly is going to hide all the details of hardware devices from the user or from the application. As I have told you, it is going to provide an abstract kind of layer in between. Then apart from that, it is going to manage main memory for the devices using cache, buffer or spooling. This cache, buffer and spooling are the we can say ways or are the tools through which main memory can be managed, or main memory can be virtually replicated, we can say. Then it also this one task of input output device management component is to maintain and provide custom drivers for each device. This we have seen earlier, that each and every device is having a device driver. So that device driver is to be provided and maintained by this particular module. With this, we have finished two modules. One is process management and another one is input output device management. I hope this is clear. You can have once again a look at the task of input output device management component, which is given on the screen. Just have a look at it. Let's start with another module, which is file management. Now all the components of your operating system are very viable, we can say, or very important. File management is one of the most visible services. File management comes in the form of storage of information in magnetic tape, disk and drum, etc. So basically here we can say, if we define what is a file is defined as a set of correlated information, and it is defined by the creator of the file. And where all this file is going to be stored? This file is going to be stored inside any of the storage device. Here the storage device which I am talking about is actually your secondary storage device. It could be hard disk, it could be magnetic tape, it could be disk, and it could be any other device like magnetic drum and so on and so forth. So now coming to the contents of the file, what this file is going to kind of contain. So mostly file represents data, source and object, forms and programs. This data files can be of any type. It could be alphabetic, it could be numeric, it could be alphanumeric, or it could be in any another we can say binary form or something. That means a file is actually a sequence of bits and bytes, lines or record whose meaning is defined by its creator and user. So with this kind of definition of files as the sequence of bits and bytes, lines or records, we need someone who is going to manage these files. Now these files can be we can have these files as shared resources also. So in order to manage these resources which can be shared in case of multiple processes, the operating system is here as a manager, and the operating system implements and abstract the concept of files by managing mass storage devices like hard disk or any other disk it could be. Now it is just a file is it's a place which we have seen that it represents data, sources, it's a sequence of bits and bytes. But please recall that files are actually organized into directories, into separate folders, in order to have a proper organization and access, and in order to ease their use. So with this definition and this background of files, what all can be the activities which are required in connection with file management. So all these activities are given on the screen, and we will go through them one by one. So first activity here is file creation and deletion. Then we have directory creation and deletion. Apart from that, we have the support of primitives for manipulating files and directories. Then we have mapping files onto secondary storage. Then we have file backup on stable, which is the non-volatile storage media. So when we talk about file management, creation of file and deletion of file, obviously on the your secondary storage devices, which are the permanent non-volatile storage devices, that things comes first into the mind. Then these files are to be organized inside the directories. So creation of directories and deletion of directories as well. Then we have various primitives or permissions related to files and directories. These permissions or files can be in the form of read, write and execute. So read primitive, write primitive and execution, all these primitives and permissions need to be supported, need to be attached with the files and directories, need to be manipulated also. Then these files are to be mapped onto secondary storage as well. And also it is not just the mapping and creation and deletion of the files, but backup of these files is also required. Then apart from this, we have the next function, which is the network management. So till this point we have seen process management, input output management and file management. Then we have network management. So network management involves several different components, but when we talk about the network management thing, first of all let's see what is network. So network is actually a process of managing and administering computer network. This is what the network management is. Now coming to the one part of, or the one single term here, which is network. What is actually a network? Basically a computer network here is a collection of various types of computers connected with each other. So in a network we have various different computers which are connected to each other, and not only the computers but all other devices like hubs, switches, routers, gateways are also part of computer network. And this is what I am talking about as the hardware devices only. We are not talking about software devices here. And managing all those devices is the component, or we can say it's the service which is provided by the operating system, and there is a small dedicated module of network management module which is going to manage all these things. So when we say network management, it's a kind of, we can say, a macro level word, but drilling down inside it, we can say this network management comprises of fault analysis, maintaining the quality of services, the performance management of network and provisioning of network also. So at the micro level of the services, this network management comprises of various things. Now in order to make the network work efficiently, it is very important that the components or the nodes of these network, which are nothing but computers, must communicate with each other properly and without any hassle. So the process of keeping your network healthy for an efficient communication between different computers is something which is, which comes under the network management thing. With this, we also have what all are the features of network management, or what all we can say are the task of network management module. So it involves network administration, network maintenance, network operation, network provisioning and network security as well. So administration, maintenance, operation, provisioning and security, also all these are the components of network management. So let me quickly recap this lecture. We have started with the various management modules, or we can say various components of operating system, and we have seen process management, input output management, file management and network management. These 4 components we have seen. All other 4 components we will be taking in upcoming lecture. Hope you have enjoyed the lecture. Here is a list of references which is being used for preparation of this talk. Thank you for a patient hearing.